Hello students, today I am going to discuss class 9th mathematics and the name of the chapter is statistic. So this is the 14th chapter, statistic. In this chapter we are going to discuss about the introduction of statistic, definition of statistic and some important terms related to this statistic, like definition, the definition of data, definition of statistic, range, frequency, class mark, class intervals, and the classification of data. And the same chapter will discuss some various types of the graphs also, like histogram, single bar graph, double bar graph, and we also calculate the central tendencies, mean, median, and mode. Let's start the first concept of your chapter, that is the definition of statistic. The definition of statistic. So what do you mean by statistic? See here, definition is given. Statistic is a branch of mathematics. Statistic is a branch of mathematics that deals with a scientific collection, organization, presentation, analysis, and interpretation of numerical data. In order to obtain useful and meaningful information. So statistic, it is nothing but it's a branch of mathematics that deals with a collection of the data, organization of the data, and presentation. We are representing the data using the tabular forms, using the tally marks also, and the same data we are going to analyze and interpret it. Interpret it means we are comparing the data and conclude the data. Okay, so this is the definition of data. So what do you mean by data? Data is nothing but data, it's a purely numerical information. The numerical information is called as a data. Okay, see, one more definition is there here. A branch of mathematics that deals with a collection, organization, and analysis of and interpretation of the data are called as a statistic. Next one, what do you mean by collection of data? Data, it is nothing but a numerical information. So how we are going to be collect these kind of the data? Collection of data refers to the process of obtaining information. We are gathering all the data from the outside sources or from the inside sources also. So the data we are obtaining from the various type of the sources, that data we are going to be collect in the systematical manner. So collection of the data refers to the process of the obtaining the information from the outside and inside sources. And next one, organization of data. Organization of data refers to that ascertaining manner of presenting the data into tables, graphs, charts, so that logical and statistical conclusions can be drawn from the collected measurements. What we are collecting the data, we need to make the systematical arrangement of the data. Once we arrange the data in the systematical order, we are going to represent the same kind of the data with the help of the graphs, charts, and we are interpreting the data. We are interpreting the data and conclude the final conclusion of the data. And next one is the analysis of data. Analysis of data is refers to that the process of extracting from the given data relevant information from which numerical description can be formulated. Analysis means in this analysis we are going to calculate the central tendencies like mean, median, mode and range of the data. We are going to calculate the mean by using various methods also, like step deviation method, assumed mean method and direct method also. Later we will discuss about that. Okay, and next one for median. Median we are having two kind of the different formulas for odd number and even number of data also. Okay, so this is the analysis of data. Analysis means the process of the extracting from the given data's relevant information from which numerical description can be formulated. Next one, interpretation of the data. So interpretation of the data refers that the task of drawing conclusions from the analyzed data. Once we are calculating the mean, median, mode or range of the data, we are going to analyze we are going to compare the data, the mean values and median values and mode values, or similarly the central tendencies. Next one, so types of the data. We are having two types of the data. First one is primary data and second one is a secondary data. So data is nothing but a numerical information. That data we are going to classify as a two types, primary data and secondary data. So what do you mean by primary data? At present what you are getting the data, that is called as a primary data. It means the number of students in the particular classroom, the number of boys in the classroom, the number of girls in the classroom, number of benches, number of windows, number of boards, number of doors. So these all are belonging to primary data. At present, at the present situation, what you are getting the data, what you are able to count the number of existing objects or existing subjects, so that is called as a primary data. Secondary data means secondary data is also numerical values. It also includes numerical values, but these data we can collect from the outside sources like internets, magazines, municipal corporations or newspapers. It means all these data we are going to obtain from the external sources like magazines, online, and next one newspapers or recognized offices also. Example, for the primary data are number of students in the particular classroom, number of boys in the particular section, number of girls, number of benches, number of doors, number of windows. So these all are the some examples for primary data. Secondary data examples. First one is number of vehicles in the particular city, number of population in the particular state, number of houses in the particular city, and number of shops in the particular state. So all these data you can obtain from the outside sources like internet, magazines, newspapers and some recognized offices. Okay, so this is the information about data. Let's see the 14.1 first question of your exercise. Give 5 examples of data that you can collect from day-to-day life. Here 5 examples are given. First one is weights of students of your class. Weights of students of our class. Second one, number of plants in our locality. Third one, number of boys and girls in classroom. Fourth one, number of runs scored by Sachin Tendulkar. And fifth one, rainfall in our city in the last 10 years. Okay, so these are the 5 examples for the datas. Let's see the next question. In second question, classify the data in question 1 above as primary and secondary. So what you wrote in the first question, you need to classify the data as a primary data and secondary data. So primary data means what? Primary data means the data collected ourselves. Secondary data means the information gathered from the another sources. Here some of the examples we already considered in the first question. Weight of the students of our classes, whether it is primary data or secondary data. This is the primary data. Second one, number of plants in our locality. It's also primary data. We can easily count the number of plants existing in our local area or locality. Next one, the number of boys and girls in our classroom. We can easily count the number of boys and number of girls in the particular classroom. Fourth one, number of runs scored by Sachin Tendulkar. We can collect these data from the magazines or online. Okay. Next one, rainfall in our city in the last 10 years. So these kind of the data we are getting from the recognized offices. So this is also belonging to the secondary kind of data. First three examples are belonging to the primary type of the data, and fourth one and fifth one, last two examples are belonging to the secondary type of the data, because these two data are collecting from the outside sources. Okay, so these are the first two questions from your exercise 14.1. okay, see the next exercise 14.2. the first question of exercise 14.2 is the blood group of 30 students of a class 8th are recorded as follows. So here 30 students blood groups are given like A, B, O, AB. Represent these data in the form of frequency distribution table. Which is the most common and which is the rarest blood group among these students? Here 30 students blood groups are given. So just with the help of these blood group, we need to make one frequency distribution table and write the tally marks also. Okay, so prepare the frequency distribution table. The first column of the frequency distribution table is blood group, second column is tally marks, and third column is number of students. In the first column, in blood group column, are taking four type of the blood groups. First one is A, B, AB and O. So here 30 students blood groups are already given. Out of 30 students, how many students are having their blood group as A? Just count this one. 1, and this is 2, 3, 4, 5, 6, 7, 8, 9. Right? So totally 9 students. This is AB. So totally 9 students are having their blood group as A. 6 students are having their blood group as B, and 3 students are having their blood group as AB, and 12 students are having their blood group as O. Here these numbers we call it as the frequencies. Once we add all the number of students, it should be equal to the number of the given datas. So the number of given datas or number of students is 30, right? So this is the frequency distribution table. Now answer the following questions. First one, most common blood group. So most common blood group is the blood group with maximum number of students, that is O. O is the most common blood group. It means out of 30, 12 students are having their blood group as O. So that's why it's the most common blood group in the 30 students. Next one, rarest blood group. Blood group with a minimum number of students. Here you are observing 9, 6, 3 and 12. So which is the least number here? 3 is the least number. So 3 is the least number means only 3 students are having their blood group as AB. It means the rarest blood group is AB. Most common blood group is O and rarest blood group is AB. So this is the answer of the first question. Let's see the second question. The distance in kilometers of 40 engineers from their residence to their place of work were found as follows. Construct here the distances are mentioned, totally 40 engineers residence from their working place. The distance from their resident to their working place is mentioned here. So construct a group frequency distribution table with a class size 5 for the data given above, taking the first class interval as 0 to 5. Here 5 not included. What main features do you observe from this tabular representation? So class interval, the size of the class interval is already mentioned. It means the width of the class interval. Width of the class interval is 5. The first class interval is also mentioned, that is from 0 to 5. So before going to arrange or before going to consider the class intervals, we have to observe which is the least value and which is the greatest value in the given data. With the help of least values and greatest value, we can easily understand the class intervals. Okay, so for first class interval is 0 to 5, second one is obviously 5 to 10, next one 10 to 15, 15 to 20, 20 to 25, 25 to 30, 30 to 35. Because the least value is here, least value is 2, so that 2 will belonging to the class interval 0 to 5. And the highest longest distance from their resident to working place is 32. It means the last class interval should be 30 to 35. Okay, we already taken here the class intervals as 0 to 5 to 30 to 35. So from 0 to 5, it means within 5 kilometers. Here 5 is not included, means we need to consider up to from 0 to 4 only. Next from 5 to 9, and next 10 to 14, next one 15 to 19, next one 19 to 20, sorry 20 to 24, and next one is 25 to 29, and the last one is 30 to 34. It means we are having two type of the class intervals, included class intervals and excluded class intervals. In included class intervals, we are not going to consider the upper limit of the class intervals. In exclusive class interval, we are going to consider both lower limit and upper limits of the class intervals. Okay. Now see here, only 5 engineers are having their residence within 5 kilometer, and 11 engineers are having their residence from 5 to 10 kilometer. Again 11 engineers are having their residence within 10 to 15 kilometer. 9 engineers are having their residence within 15 to 20 kilometer, and next one is only 1 and 1. 1 engineer from 20 to 25 and 25 to 30. And last one, 2 engineers are away from their working place and their distance is 30 to 35 kilometer. Now answer the following questions. With the help of this fixed frequency distribution table, you can answer the following questions. First one, we see that the minimum value is 2 here and the maximum value is 32. So we can take the class intervals as 0 to 5, 5 to 10 and 10 to 15, like this up to 30 to 35, because the smallest number is 2, that is belonging to the first class interval 0 to 5, and the last highest value is 32, it is belonging to the last class interval, that is 30 to 35. With the help of this frequency distribution table, we can observe that there are very few engineers who come are at more than or equal to 20 kilometer distance from their working places. Most of the engineers have their workplace at distance of 0 kilometer to 15 kilometer distance from their homes. Here you are observing 11 and 11. The total strength of the engineers is 40. Out of 40, 22 engineers are having their residence within 15 kilometer. It means more than 50% of the engineers are having their residence from their working places within 15 kilometer. So this is the conclusion of the given question. Let's see the third question. The relative density, the relative humidity in percentage of a certain city for a month of 30 days was as follows. So humidity means the presence of the water molecule or the presence of the moisture content which is present in the atmospheric air. So that is called as a humidity. Humidity means the presence of air or the presence of moisture content in the atmospheric air. Okay. So here the relative humidity in percentage of a certain city for a month of 30 days was recorded, and the data are as follows. Construct a grouped frequency distribution table with classes 84 to 86, 86 to 88, and the next class interval is obviously 88 to 90, 90 to 92, 92 to 94, 94 to 96, and 96 to 98. So before going to construct the class intervals, first you need to identify which is the least value and which is the maximum value. The least minimum value is 84.9 and the maximum value is 99.2. It means the first least value is belonging to the class interval 84 to 86 and the last maximum value is belonging to the class interval 98 to 100. So with the help of these lowest and highest value, we can easily write the class intervals. So these are the class intervals from 84 to 86 and the last class interval is 98 to 100. Now the humidity percentage lies between from 84 to 86. Only one value is lies between from 84 to 86. From 86 to 88 also only one value is there. From 88 to 90 and 90 to 92 two values are given. It means 2% are lies between from 88 to 90 and 90 to 92. And next one from 92 to 94 7% values are lies between from 92 to 94. and 6 days humidity value is lies between 94 to 96. 7 days humidity value is lies between 96 to 98, and 4 days humidity value is lies between 98 to 100. So once we add all these humidity or number of the days, we get the total number of days, that is equal to 30. Now see the question. With the help of this frequency distribution table, we can easily answer the following questions. Which month or season do you think this data is about? Relative humidity is high, so the data is about a month of rainy season. In rainy season, we are going to observe the highest humidity will be present in the air. And second one, what is the range of this data? How we are going to calculate the range? Range means that indicates the expansion or expanding nature of the data. How much the data will be expanded, or how much the data will be spreaded. So that range we can calculate by using the formula. Range is equal to highest value minus lowest value, or range of the data, which is equal to maximum value minus minimum value. So maximum value is 99.2 and minimum value is 84.9. Therefore the difference of these two values is 14.3. Hence the range of the given data is 14.3. Okay, let's see the fourth question of your exercise 14.2. The heights of 50 students measured to that nearest centimeters have been found to be as follows. So totally 50 students height as measured. You need to represent these data in the frequency distribution table and answer the following questions. Represent the data given above by a grouped frequency distribution table, taking the class intervals 160 to 165, 165 to 170, etc. So before constructing the frequency distribution table, you need to observe the least value and highest value, minimum value and maximum value. And the minimum value is 150. Minimum value is 150 and maximum value is 173. If minimum value is 150, means the first class interval should be start from 150 to 155. The width of the class interval is already given, that is 5. That's why we are taking here from 150 to 155. And the next class interval is 155 to 160, 160 to 165, 165 to 170, and 170 to 175. Here the 50 students height is already given. In that 12 students are having their height between 150 to 155. 9 students are having their height between 155 to 160. 14 students are having their height 160 to 165, and 10 students having their height between 165 to 170, and only 5 students are having their height between 170 to 175. Now what can you conclude about their heights from the table? Already tabulating the given data. With the help of these 50 students height, we are making the frequency distribution table. Okay, now what we are going to conclude with the help of this frequency distribution table? Here you are observing 12, 9, 14. Maximum number of students 12, 9, 14. Maximum number of students having their height more, it should be more than 50%, right? So students shorter than 165 centimeter, it means here we are considering the students, they have their height as less than 165 centimeter. 12 students, 9 students and 14 students. Once we add all these three, we get a 35. So out of 50 students, 35 students are having their height within 165 centimeter. It means more than 70 percentage of the students in the particular class interval or in the particular section, 70 percentage of students, their height is less than 165 centimeter. It can be concluded that more than 50 percentage of students are shorter than 165. So this is the conclusion of the given question. Okay, see the next one, fifth question. A study was conducted to find out the concentration of sulfuric dioxide in air in parts per million, ppm. Ppm means parts per million. Of certain city. The data obtained for 30 days as follows. Here 30 days datas are recorded. With the help of these datas, we can construct a frequency distribution table. Okay, make a grouped frequency distribution table for this data with a class interval 0 to 0.04 to 0.04 to 0.08 and so on. Before constructing these frequency distribution table, first observe the least value. It means minimum value and maximum value. So minimum value is 0.01 and maximum value is 0.22. It means, so we can take the class intervals as 0 to 0.4, 0.4 to 0.8 and 0.8 to 0.12, 0.12 to 16, 0.16 to 0.20, 0.20 to 0.24, because the least value which belongs to the first class interval, that is 0 to 0.04, and the highest value, maximum value, is 0.022 and it is belonging to the last class interval, that is 0.20 to 0.24. Here in 4 days, the sulfur dioxide concentration is lies between 0 to 0.4. 9 days having the concentration between 0.04 to 0.08. Again the same 9 days, next 9 days having the concentration of sulfur dioxide, and the value of the concentration is lies between from 0.8 to 0.08 to 0.12. And the next one, 2 days, 4 days and 2 days. These datas are belonging from 0.12 to 0.16, 0.16 to 0.20 and 0.20 to 0.24 respectively. So totally once we add all these datas, number of days, it should be equal to 30. Now see the question, for how many days was the concentration of sulfur dioxide more than 0.11 parts per million? Number of days where concentration of sulfur dioxide is more than 0.11 is number of days where concentration is in between 0.12 to 0.16 plus number of days where concentration between 0.16 to 0.20 plus number of days where concentration between 0.20 to 0.024. So totally in 8 days we are going to observe the concentration of the sulfur dioxide more than 0.11. So totally out of 30 days, 8 days have the concentration of sulfur dioxide is more than 0.11 parts per million. Okay, see the next question. The next question is, 3 coins were tossed 30 times simultaneously. Each time the number of heads occurring was noted down as follows. So once the toss is coin once the coin is tossed means we will get two outcomes. Either it should be head or tail. So once we are tossing single coin, we will get two outcomes. If we are tossing two coins at the same time, we will get totally four outcomes. At the same time, by tossing three coins simultaneously, we will get 8 outcomes. Later we will discuss in the probability chapter. So here 3 coins were tossed. Time, 3 coins were tossed 30 times simultaneously. Each time the number of heads occurring was noted down as follows. So prepare the frequency distribution table with the help of the given datas. You need to prepare the frequency distribution table with the help of these given datas. So 6 times we are getting 0 number of heads. It means it's purely tail only. Next one, 10 times we are getting 1 number of heads, 1 time head. 9 times we are getting 2 times of head, and 5 times we get 3 coins as a head. So totally by adding all these frequencies, it should be equal to 30. So this is the frequency distribution table for the given question. Let's see the 7th question. The value of pi up to 50 decimal places is given below. So we already know the value of pi, that is 3.14159265 and so on. Okay, after some digit the same digits will be recurring. So these kind of the decimal expansions, we call it as a recurring and repeating decimal expansions. Make a frequency distribution table of the digits from 0 to 9 after the decimal point. What are the most and least frequently occurring digits? So after 3 point, we're having some digits like 14159265. We need to make a frequency distribution table after decimal point. So which digit will come? Repeat more time. So 2 will repeat 0 times. So 0 will repeat 2 times. 1 will repeat 5 times. 2 also repeats 5 times. 3 repeats 8 times. 4 repeats 4 times. 5 repeat 5 times. 6 repeat 4 times. 7 repeats 4 times. 8 repeats 5 times. And 9 repeats 8 times. Here we are having the datas. With the help of these datas, the frequency distribution table is constructed. So with the help of this frequency distribution table, answer the following question. What are the most and least frequency occurring digits? Here you are observing 0, the digit 0 repeat only 2 times. So that's why the least frequently occurring digit is 0. It repeats only 2 times. And next one is maximum repeated number or maximum repeated digit. Maximum frequently occurring digit is 3 and 9. These two digits 3 and 9 repeats 8 times. 8 times these two digits will be repeated. So the minimum repeated number is 0, or minimum repeated digit is 0, and maximum repeated digit is 3 and 9. Okay, let's see the next question. And the next question is 30 children were asked about the number of hours they watched TV programs in the previous week. The results were found as follows. Make a grouped frequency distribution table for this data taking class intervals 5 and one of the class interval as 5 to 10. So here 30 students are asked to their time to watch the televisions. Okay, and their time is recorded as follows. First, observe the least value. It means minimum value and maximum value. Minimum value is 1 and maximum value is 17. So minimum value 1 means the class interval, width of the class interval size is already given, that is 5. So 5 means the first class interval should be 0 to 5, second one 5 to 10, 10 to 15, 15 to 20. Okay. Now 10 students are watching TV 10 to 4, 10 to 0 to 5 hours. 13 students are watch TV 5 to 10 hours. 5 students are watch TV from 10 to 15 hours, and only 2 students are watch TV up to 15 to 20 hours. So once we are adding all these numbers, it should be equal to 30. How many children watched television for more than 15 hours in a week? Only two children are watch TV more than 15 hours per week. Okay, see the next question. The next question is, a company manufactures car batteries of a particular type. The lives in years of 40 such batteries were recorded as follows. The lifespan of the batteries are recorded as follows. Construct a grouped frequency distribution table for this data using class interval of size 0.5 starting from the interval 2 to 2.5. So before constructing this data, we need to observe the least value, minimum value and maximum value. Minimum value is 2.22. 2.2 is the minimum value and maximum value is 4.6. So minimum value is 2.2 means the first class interval is obviously 2 to 2.5 and second one 2.5 to 3, 3 to 3.5, 3.5 to 4, 4 to 4.5, 4.5 to 5. Because the highest value or maximum value is 4.6, that's why we need to take the class interval, last class interval as a 4.65 to 6. So 2 batteries having their lifespan 2 to 2.5 years. 6 batteries are having their lifespan as 2.5 to 3 years. 14 batteries having their lifespan as 3 to 3.5 years. 11 batteries have their lifespan as 3.5 to 4 years. 4 batteries have their lifespan as 4 to 4.5 years. Only 3 batteries are having the highest lifespan in the mentioned class interval, that is 4.5 to 5 years. Okay, so this is the frequency distribution table for the given question. In this frequency distribution table, we can easily understand which type of the batteries will be manufactured from the particular company. So with the help of these data, we can easily conclude that maximum number of the batteries are having the lifespan of, that is 3 years to 3.5 years. Okay, So these are the some of the questions from your exercise 14.2. In the next class, we will discuss about the remaining exercise. Till then, be happy. Have a nice day. Thank you.